Bismillahirrahmanirrahim. Assalamualaikum. Today we're gonna present our assignment 2 about selective catalyst reduction. And this is our group members: Akmal Hakim, Aiman Ashri, Muhammad Harith, Ahmad Faidhi, and Muhammad Farid. Next. And for the first is our agenda. We're gonna present about introduction, history, theory of operation, system or technology diagram, advantage and disadvantage, opinion, and last opinion on the technology for the future. Next. Okay, for the introduction, the Harith Corporation obtained a patent for selective catalytic reduction of using ammonia as the reducing agent in the United States in 1957, commonly found on big utility boilers and industrial boilers and municipal solid waste boilers. Diesel engines such as those seen a huge ship, diesel locomotive, gas turbine, and even automobiles are example of more contemporary usage. The selective catalytic reduction or SCR system injects a liquid reductant agent through a unique catalyst into the exhaust stream of a diesel engine. Nitroxide reaction can happen in an oxidizing environment thanks to SCR technology. It's referred to as a selective because it uses ammonia as a reductant in a catalytic system to lower nitrogen oxide levels. The process is referred to as a reduction, and the reducing agent in this reaction is DEF, which interacts with nitrogen oxide to transform the pollutants into nitrogen, water, and trace amount of carbon oxide.
Okay, for the theory of operation, how this SCR function is when the gas move through the catalyst chamber, the oxide, okay, either nitro oxide or NO, reduction process happens. The gases are mixed with ammonia or another reductant such as urea. Yeah, urea is a protein. It's a protein combination of mixed protein that can be found in the SCR and also for the human body. Okay, before they enter the catalyst chamber. The chemical equation for the stoichiometric reaction employing either anhydrous or aqueous ammonia is as below. Okay, there are three types of ammonia, which all of them will produce nitrogen gas, nitrogen in the form of gas, N2, and also water, H2O. Okay, the optimum reaction can function at temperature as low as 500 Kelvin, which is equal to 227 degrees Celsius. With extended residence durations, its best temperature range is between 630 and 720 Kelvin. In Celsius is 357 degrees Celsius and 447 degrees Celsius. The diesel exhaust fluid or DEF is sprayed onto a unique catalyst as hot exhaust gases from the engine enter the SCR system. The nitrogen oxides in the exhaust are changed into nitrogen, water, and trace amounts of carbon dioxide, CO2, to a chemical reaction that is sparked by the DEF, the diesel exhaust fluid, and takes place on a specific catalyst. Thank you.
So we move to the part of system diagram. So as you can see, this is an example of selective catalyst reduction SCR system. As you can see, the red flow is the exhaust flow, and meanwhile the blue is the diesel exhaust fluid. So ammonia is used in selective catalytic reduction technology to break down hazardous nitrogen oxide emission produced by diesel engines into nitrogen and water. In automotive application, SCR provides ammonia via a urea solution. known as a diesel exhaust fluid (DEF), which is injected into the exhaust stream by an improved injection system and then convert to ammonia on a specific catalyst. SCR is the technique of choice of the majority of vehicle and engine manufacturers to meet heavy-duty truck emission requirements in 2010. Aside from the environmental benefits, the most significant advantage of SCR for vehicle user is the increased fuel efficient. Engineers may adjust the engine to provide more torque while consuming less gasoline. Because SCR deals with emission in the exhaust pipe, SCR has been widely adopted on diesel vehicles. By the end of 2010, more than 1 million trucks and buses in Europe alone had the technology. Okay, next.
Okay, for advantage and disadvantage. For advantage, we got 2, and disadvantage, we got 5. Okay, we're gonna elaborate the advantage first. The advantage of the SCR is the higher NO reduction yield in comparison to the SNCR technology, and installation is not very complicated, which is plug and play. For the disadvantage, in order to prevent the condensation from occurring, the operation must be carried out at temperature that is relatively high while the SO3 level is relatively high. The flue gases produced by high dye switching include a significant amount of NH3. Aspect related to the cost of the catalyst, which is very expensive for the catalyst. There is a possibility that flue gases will erode the catalyst over time, and cost of investment is highly comparison to the SNCR.
So, okay, for our opinion, one of the advantage of SCR is that it is often capable of achieving a reduction in NOx emissions that are far higher than 90%. This can contribute to the reduction of air pollution and the improvement of air quality. When SCRs is requires little in the way of energy and has modest running costs for the reducing agents. One of the difficulties that in order for it to be effective, it needs to be a particular kind of a catalyst, and this catalyst can be rather expensive and need to be replaced on a regular basis. For the development of catalysts that are more robust and cost effective, as well as the development of catalysts that are more robust and as well as those that do not require frequent replacement, could be one way that SCR could be improved.